Hi and welcome to Quick Math. In this segment, we shall be discussing sequence, proportion, and functions, with specifics including types of sequence, direct and inverse proportion, and the introduction of functions. We shall start with the topic sequence, which is a list of numbers or objects that take up a certain order. For example, 1, 2, 3, 4, 5, or 2, 4, 6, 8, 10, or 2, 4, 8, 16, and 32. The first two sequences on the previous page are called arithmetic sequence, where the subsequent number is a form of addition or subtraction against the current number. The third sequence from the previous page is a geometric sequence, where the subsequent number is a form of multiplication or division against the current number. Besides the arithmetic sequence and the geometric sequence, there is a square number sequence, a cube number sequence, a triangular number sequence, where an incremental integer is added to the last number, a Fibonacci number sequence, where the subsequent number, starting from the third number, is the sum of the two numbers before it. Enough in definitions, so let's now take on tutorial question 1. Do press the pause button as required. What comes next for the arithmetic sequence 109, 98, 87, and 76? The answer should well be 65 and 54. This is obtained by subtracting 11 from the last number. Tutorial question 2. Do press the pause button as required. What comes next for the geometric sequence 450, 90, 18? By dividing by 5 for the 4th and 5th solutions, they are 3.6 and 0.72. This question is also meant to show that the sequence can be that of ascending, or in this case, descending order. Tutorial question 3. Do press the pause button as required. What comes next for the sequence 3, 8, 18, and 38? By adding 1 to the last number and then doubling it, you should get 78 and 158 respectively. Next, we shall discuss proportion, which is used to relate two varying quantities. The most common type of proportion is direct proportion. Direct proportion can be represented with a ratio. For example, if 5 tennis balls have a mass of 290 grams, what would be the mass for 9 tennis balls? For this question, the first representation can be put as a ratio 5 to 290, and this would equate to 9 to what we choose to find. By doing the math, we should arrive at the answer 522. The table below is an example of another event involving direct proportion. The inverse of direct proportion is simply inverse proportion. We use inverse proportion for relating change in the same ratio, but with one quantity becoming smaller when the other becomes bigger. For example, it takes a shorter time to get to the destination if we drive at a higher speed. Also, a job at a construction site can finish in fewer days if we have more people at work. The table below is one more example of inverse proportion, coming from the question, if a farmer has a fixed amount of food to feed his 10 sheep for 8 days, how will the situation change if he decides to get more sheep, assuming he does not get more food for the sheep. In wrapping up, the product of the two varying numbers are the same outcome for all cases of inverse proportion. Back to tutorial questions. So do press the pause button as required. Question 4 reads as, if I can sell 10 apples for $90, how much can I make in selling 60 apples? By applying direct proportion, you should arrive at $540. Tutorial question 5. Do press the pause button now as required. If it takes 10 people 10 days to make 10,000 masks, how many people will be required to make the same number of masks in 2 days? For this question, you would apply the inverse proportion. Also, the quantity of masks has no purpose here. The product of people and days in the first representation is 100. Therefore, the number of people that will be required to make the same number of masks in 2 days is 50. Now, we get on to functions, which is represented by an input and an output. And when an input is made, the function can be thought of as processing the input in some way to provide the output. This page organizes the pictorial view of a function in the first column. It demonstrates what output is obtained based on a predetermined set of inputs in the second column, and how the function can be represented mathematically in the third column. Row 1 simulates each of the three when the process is to add 2 to the input. Row 2 for when input is multiplied by 2. And row 3 for when the input is the order of the number 3. Now, doesn't it seem like the first two rows are that of an arithmetic sequence, and the third row is that of a geometric sequence? Let me also show you here how functions can be mathematically represented for direct proportion and inverse proportion. In summary, we can adopt functions to resolve mathematical problems, be it a direct proportion or an inverse proportion. Now back to tutorial questions, so please press the pause button now as required. Question 6 reads as, what comes next after the sequence 4, 10, 28, and 82? If you watch the numbers closely, these numbers represent a cube number sequence that had been added by 1. Therefore, the number that comes after 82 is 244. Tutorial question 7. Do press the pause button as required. What function best represents the sequence 4, 10, 28, and 82? It should be the expression 3 to the power of x plus 1. Tutorial question 8. Press the pause button as required. What function best represents the formulation of the ratio 4 to 7 when the input is represented by the first number and the output providing the second number? It should be the middle one amongst the three we have to choose from. Tutorial question 9. Do press the pause button now as required. What function best represents the following inverse proportion type of question? It takes 30 minutes to drive to David's house when I drive at an average speed of 40 kilometers per hour. At what average speed must I drive to arrive against a given duration? The last representation is the correct answer. That's all for sequence, proportion, and functions. If this had been useful to you, do look out for other segments with the header Quick Math.